If math has been driving you crazy, or if you're finally admitting you're lazy, and your test grades have been dropping, it's time to get your arrows popping.
Hello, everyone. This is Mr. Witt with Fort Bend Tutoring, and today's final exam review is going to be over intermediate algebra. Angry Hermit is in the house. Gina Ramirez is ready to go. Charmaine is in the house. How you doing out there, guys? We have a great final exam review today. Angry Hermit says, I've kind of been looking forward to this all day. Well, so have I. So have I, guys. And in our first problem, we're going to be giving the domain of f of x equals to the square root of x minus 3. And just to remind you guys that this final exam review is going to be a two-parter. Today is going to be part 1. We'll be going over approximately 20 problems dealing with Math 0312, intermediate algebra, the final exam review that is offered at many junior colleges, community colleges, and a few universities. And Ash is in the house. Ash is from my class, guys, at HCC. So we got Ash up in this piece. How's it going, Ash? Good to see you here live with your instructor. Nice. All right. Saya's in the house, holding down the moderator duties, as well as Angry Hermit. And please, guys, go ahead and feel free to share the stream with your friends and family and all that good stuff. Go ahead and like and subscribe to Fort Bend Tutoring. And if you want to represent us out there in the public, you guys can purchase one of our FBT t-shirts from fortbendtutoring.spreadshirt.com. The link is in the description box. We got Gigi. There you go. Gigi from my class as well at HCC. Awesome. Samantha says, Mr. Witt. Oh, no. Samantha, don't go about failing your GMAT. Go ahead and get some help. And Fort Bend Tutoring can definitely help you, Samantha, as far as the math portion of the GMAT. We don't do the entire exam, but we do help you with the math portion, the arithmetic reasoning aspect of that test. Jonathan's in the house. Jonathan says, I have to write my CXC exam in 2 weeks. Muthani says, hello. So we have everybody up on this piece today in the house. Got my students in the house. I'm happy to hear that. Happy to see that out there in the live chat. And we got Jenny in the house, another student of mine, ready to go. Good stuff, Jenny. Good to see you. And so we're going to get this thing started because I want to get through as many problems as possible today. You guys can chat amongst yourself. Sebastian says hi. And also, just to remind you guys, as always, that we want to reach as many people as possible. And, of course, we can do that with your help. Joanna's in the house. Alexis is in the house. And that means that you can donate to Fort Bend Tutoring. We have a link in the description box, as well as we have the option for Super Chat located at the bottom of the live chat there, the super chat. You can see the dollar symbol there, and that's where you can offer up a donation. So if you want to be immortalized on our YouTube channel, if you go ahead and leave a donation, we will go ahead and put you right here on the screen. That's right, to show you some love right back to you for helping out FBT and helping everyone around the world with their math. All right, well, let's get started, guys. In order to find the domain of f of x, you have to first of all realize that we have a domain restriction in play. Our domain restriction that we have to be concerned with is the fact that you have a square root sign. And that square root sign, when dealing with real numbers, means that you cannot have any negative values as a radicand. That's right, the value underneath the radical symbol there, it can't be negative, because if it's negative, it's undefined. That's right. So we got somebody chiming in from Greece, guys, and Lydia says, if I'm pronouncing that correctly. If I didn't, I apologize. Hello from Greece. Your videos are very helpful. Thank you. I appreciate that. Let's try to make this one helpful for all that chimed in for intermediate algebra final exam review. All right, so let's make this popping, guys. Okay, so bottom line is we have a function. It's the square root function that we're dealing with, and we can't have any negative values. You can't take. Thank you. Lydia is in the house. All right, Lydia, thank you so much for clarifying that. Thank you for chiming in, and thank you for chiming in from Greece. All right, Greece represented. Down with the Greeks. FBT and the Greeks. That's what's up. So we're going to set our radicand like this. We'll say that x minus 3 has to be greater than or equal to 0. Once again, our domain restriction for this particular function is that you can't take the square root of a negative value. Therefore, when they're asking you to give the domain of f of x, they're saying what values of x can be used in this function without violating any restrictions on it, without violating the domain, without making the problem undefined. That's what we're trying to identify here. So when they're asking you to solve for the domain, you just take the radicand, and in this case, the x minus 3, set it greater than or equal to 0, and then solve for x. Tracy is in the house saying thank you for all that we do, all that I do. Well, it is my pleasure, Tracy. So what I'm about to do right now is solve for x. So let's go ahead and first of all, get to some black. I need to be writing in black right now. What is wrong with me? So we're going to be adding 3 to both sides. That's what's up. Say it says nice. We have x is greater than or equal to 3, and this is a domain. But you can write your domain in different ways. So some will actually have you write it as what you see right there. Okay, that x is greater than or equal to 3. Those are the values that you can choose for x in this particular function, so that you do not have any undefined result. Okay, so another way to write it is using interval notation. So let's just say we have this on a number line and we show where 3 is on that number line. We can use a bracket because this is greater than or equal to 3. So we use a bracket to indicate that one of the solutions, one of the values that can be in the domain is 3, and then everything to the right of 3. So I'm shading to the right here. Okay. So let's make that look cuter for some reason. All right, that's a little better. And using interval notation, it's a direct translation of our number line here. We'll have the domain being greater than or equal to 3. Oh my God, is that an infinity symbol? There we go. Better. So as interval notation, Brenda's in the house. Thank you for being such an awesome teacher. Thank you so much, Brenda, for being such an awesome student. How about that? So our interval notation is another way to show our domain. You can also set it up in set builder notation. So depending on your the author of the test, depending on the teacher, depending on the exam that you're taking, they may have the domain represented in several ways. One of these ways could be just simply the solution of x when you have it set greater than or equal to 0. You could have it written as a graph. You can also have it written in interval notation, and you can also write it in set builder notation. So if I can bear with myself just a second to write this in set builder notation because my braces suck. There you go. There's set builder notation. Charmaine, you should be able to donate by using the donation link that's found in the description box. All right. So that should be the easiest way for you to do that. All right, ladies and gentlemen, it is time to red box it. Samantha, you can find out our fees on our website, which is tutormemath.net. I'll go ahead and throw a link in there and you can see how much we charge. All right, let's go ahead and click over here real quickly while I put in there we go. Boom, there is the link. So you can check out our fees and whatnot. Aspect says, hey, Mr. Witt, because of you, I have a 93 average here at the end of my intermediate college math course. You are amazing, Aspect. And thank you so much for using our services. I appreciate that. Charmaine, if you have any difficulty donating, just go ahead and email us, and we will send you back a better link. But the link that's in the description box below this video should be working just fine. All right. And Aspect says that he or she has always been bad at math, but FBT videos have helped out. Sonia's in the house. You're awesome. Watched you raise my grade. All right, watching you raise my grade. That is awesome. Thank you for getting some benefit out of our videos, guys. And as I said before, it's time to red box this answer. We got problems to go through today. I want to talk to you guys forever, but I won't get any work done. So I'm going to have to kind of balance this out. Aspect says arrows popping. Absolutely, Aspect. You got to have those arrows popping when you bring your grade up with FBT already. So once again, let's recap on number 1. They asked to give the domain of f of x. We recognize that this was a square root function. And when dealing with a square root function, you cannot take the square root of a negative number when dealing with real numbers, real numbers, not imaginary numbers, not complex numbers, but real numbers. So therefore we set the radicand, aka the value underneath the square root sign, we set that greater than or equal to 0. That's exactly what we did. Yeah, and then we solve for x. Victor says, excellent videos, man. I have my final tomorrow. Well, that's why I wanted to do this today, Victor, so I can help people. You know, I want to help somebody. Let me help you. Thanks. Let's look at problem number 2, guys. Problem number 2. Hey, Victor, good luck for on your final exam, for real. And hopefully today will help out. In number 2, it says, use the square root property to solve the equation. Guys, I have a secret to tell you guys. The square root property video that is on Forbidden Tutoring's channel is basically showing you a shortcut of sorts. I mean, it's correct. I mean, you can get the right answer, but it's not really fleshing out the square root property as you should see it as a math student, as a mathematician in development. So what I'm going to do, I'm going to show you the right way right now with this problem with number 2. So let's recap on the instructions here. For number 2, it says use the square root property to solve the equation. We have the quantity of x minus 6 squared equals 16. And Mr. Witt is about to kill this problem for you right now. That's right. I got my orange juice with no pulp ready to go. I'm about to kill this problem. That's what's going on. Angry Hermit put a link in the description box, guys, in the live chat for the video for the square root property. But I want to show you guys the full-fledged square root property by Mr. Witt right now. Let's kill this problem. Your first step, guys, is to isolate the quantity that's being squared. Isolate the quantity that's being squared. Get the value that's raised to the second power that contains your variable x by itself on one side of the equal sign. And in this case, we already have it the way it should be. That's right. See this x minus 6 squared? It's already isolated. It's already on one side of the equal sign. That's what we want. So what we'll do is we'll do the square root of this x minus 6 squared to both sides of the equal sign. All right. There we go. There we go. I got something on the screen. Let's fix that. There we go. Better. Better. Let me calm down a bit. Okay. Don't want to make any mistakes. All right. Just bring it down just a tad. The square root sign, your radical sign here, guys, it always means to take the positive root, aka the principal root of the value underneath. That means that any end result of taking the square root must be positive. It's not that the negative root doesn't exist. I mean, we all know that negative 4 times negative 4 will give us 16, right? We also know that 4 times 4 will give us 16, right? So they're not discarding the fact that the negative root exists. Oh, no. It's just that the radical sign itself means to find the principal root. It means that they're looking for the positive root of the answer. Okay? So because the square root sign means that you should always have the positive root in play when you're using it, that means that when I take the square root of the left side, I have to guarantee that this value, x minus 6, is positive, which is why we need to have absolute value signs around that value. We're guaranteeing that the result will be a positive result. Remember, the operation of taking the absolute value is a distance problem to 0, so therefore the end result will always be positive or 0. So we're saying that the square root of x minus 6 squared must be a positive answer. And how do you guarantee that with a variable? You put absolute values around it. You put your absolute value signs around that result. That's how you do that. And on the right side, the square root of 16 is just 4. You see? So already what I'm showing you is different from what you'll find in the video where I'm just basically using a shortcut. Okay? So this is the reason why we're able to use the shortcut that you'll find in the video that I made. Okay? So once again, that square root property video, as far as getting the correct answer, is A-OK. No problems there. But this is more of the why the answer is what it is. Okay? Because at this point right here, we have an absolute value problem. Yeah. And with this absolute value equation, the answer must be positive. Okay? Or it's 0 for that matter. And it is. Our absolute value of x minus 6 does equal to a positive answer. Angry Hermit says, can you always use a radical to cancel out a square? You can always use a square root to cancel out the square. Yes, Angry Hermit. But let's just say that you had a cube root. Then you can cancel out a perfect cube. So it's going to be respective to the exponents that you have in play. That your root, if it matches your, if your root matches your exponent that you're being that the quantity is being raised to, then yes, it'll always cancel out. Because our root here, our index is 2. We assume that the index is 2. That's why it's canceling out that 2, that square right there. Okay, so it's basically dividing. 2 divided by 2 gives us this quantity raised to the first power. So yeah, there you go. Now we're solving an absolute value equation, guys. Let's get to it. Solving this absolute value equation, our quantity here must be, okay, positive or 0. We have it set equal to a positive number. Therefore, x minus 6 can equal to 4 to be 4 places away from 0, or it could be 4 places away from 0 at negative 4. So once again, the reason why you're going to end up with 2 equations to solve is because our distance to 0, this absolute value says you need to be 4 places away from 0. We can be 4 places away from 0 at negative 4 and at positive 4. Chase says, is this freshman algebra 1? Yes, Chase. A lot of this will coincide with the course Algebra 1. Absolutely. But this course is also offered in college settings to get students college ready for college algebra. So will this line up a lot with your Algebra 1 freshman class in high school? Absolutely it will. Yeah, it will. So you will benefit from watching this video, Chase. All right. So let me know how that works out. But just to let you guys know, next week is college algebra. Oh, yeah. So for those of you in college algebra, check out the final exam review for next week, because we're going to be killing some problems. And then soon after that, Chase, I'll actually be doing an Algebra 1 final exam review. All right. So I got you guys in mind as well. All right. So let's recap. You start out by isolating the quantity that's being squared, guys. Using a square root sign means that you should always have the positive root. And once you have the positive root here, you'll end up with an absolute value equation. Because the absolute value is asking you for the distance to 0, you'll have 2 different equations set up where 1 equals to positive 4 because that's 4 places away from 0, and 1 set equal to negative 4 because that is also 4 places away from 0. And then you will solve for x. And we'll do that by adding 6 to both sides of the equal sign. So in our first equation here, x equals to 10. And then in the second equation, x will equal to positive 2. So our 2 solutions for this problem, let me go ahead and see if I can get it right here with a decent brace. Nope, the brace is ugly. Once again, Mr. Witt not being able to draw a brace to save his life, but has the solutions, red box in it, and there we go. There you go, guys. That is the solution. And just to let you know, okay, that if we plug in 2 into our original equation, 2 minus 6 is negative 4. Negative 4 squared does equal to 16. That works. Plugging in the number 10. 10 minus 6 is 4. 4 squared is 16. 16 does equal to 16. So therefore we have the correct solutions for this problem, guys. And that is the proper way to do the square root property. I'm glad you guys hung in there with me. Once again, taking the square root of both sides, making sure that your left side is the absolute value of that quantity x minus 6 after you take the square root of it, and always keeping in mind that when using a square root sign, a radical sign there, this particular radical sign, your result must always be the principal root, aka the positive root. Done and done. Joanna Jones, absolute values was tough at first, but once you explained it, I got it. Thank you very much, Joanna. We have just red boxed it. And now we're on to problem number 3, guys. On to problem number 3. Thank you so much, guys, for chiming in with me today. I really appreciate it. Spread the word by sharing your stream on your social media. I really will appreciate that. Let's bring everybody involved that can be here, present and accounted for. Like the video. Make sure you're subscribing to Fort Bend Tutoring, as we will be regularly bringing you information that will help you in your academic endeavors. Yeah. Number 3. Find the equation of the line through the point negative 3 and 8 and perpendicular to negative 3x plus 4y equals negative 23. Write the equation in slope-intercept form. So the first thing you want to find out about this particular problem is the slope of the given line. Yeah. Joanna is lying to me, guys. Joanna says that my braces look nice, but I appreciate the thought, Joanna. I know you're saying something kind, something that my ears need to hear, but my eyes see jacked up braces. But I appreciate it nonetheless. Thank you so much for your support, Joanna. All right. So there you go. Joanna's an angel, guys. All right. She's doing God's work. Definitely making me feel good. Appreciate it. So here we're going to go ahead and start with this negative 3x plus 4y equals negative 23. In order to solve, one of the ways that we can find out what the slope of this line is to solve for y, aka put this into slope-intercept form. Remember that slope-intercept form is, let's go ahead and put this in green here. Slope-intercept form is y equals mx plus b. Once you put a linear equation in this form, you can quickly identify what the slope of the line is. We need to know what the slope of this line is in order to come up with a perpendicular line slope that we can use to create our answer, our linear equation that will be perpendicular to this line and going through the point negative 3, 8. So by solving for y, that means I'll be adding 3x to both sides of the equal sign, guys. I'm going to be bringing down this 4y equals to 3x minus 23. I'll be dividing each and every term by 4. Oh, yes, I will. And I'm going to end up with y equals 3/4 x minus 23/4. And the slope of this line is 3/4. Yeah, it is. The slope of this line is 3/4. However, we need the perpendicular line slope. So if this given line has a slope of 3/4, then the perpendicular line slope is going to be the opposite reciprocal of that, meaning that you change the sign of that slope that's given and you flip it. Yeah, you find the reciprocal. I mean, you can put the denominator in the numerator and the numerator in the denominator. That's what I mean. I mean, that's what that's what has to happen to make you end up with the perpendicular line slope. So if I'm starting out with a positive 3/4 slope, you're going to end up with a negative 4/3 slope. You only do this when you are dealing with a perpendicular line slope. Do you hear me out there? Okay. So let's go ahead and take this information to the other page here. Let's go ahead and hook this up. I think I need to add a page here. Let's add a page, guys. There we go. Let's hook this up. Add this page. There we go. We know that we have the perpendicular line slope set at negative 4/3, right? Because we started out with 3/4. We changed the sign, we flipped it, ended up with negative 4/3. This line has to go through the point negative 3, 8, right? And they want the answer to be in slope-intercept form. So what we'll do is we'll start by labeling our point x1, y1. And what we'll use, aspect is saying that he hears me, he or she hears me. Appreciate that, aspect. Thank ya. And put a WHITT on that, aspect. Okay, I don't play around with that WITT crap. It's WHITT. Get my name right, bruh. Just kidding. Or am I? So we'll have the point slope form that I'll use. We'll have y minus y1 equals to m times x minus x1, and we'll plug in the given slope as well as my y1 value, which is 8, which equals to negative 4/3 times x minus my x1 value, which is negative 3. All right, so this may look like a little hot mess for a short while. So we'll end up with y minus 8 equals to, I'm going to take my time with this. I'm going to combine those signs within the parentheses here because the opposite of negative 3 is positive 3. So this is what I have so far, guys. All right. And once again, I'm using point slope form. Thank you very much, aspect. And yes, Angry Hermit, I'm just as fussy as you are. So then we're going to distribute. Get my arrows popping, ladies and gentlemen. You know I love the distributive property. So we're going to be bringing down the y minus 8 equals to negative 4/3 x. And when I multiply negative 4/3 times 3, those 3's will cancel out to leave me with negative 4. Oh, that 4 is ugly. Fix the 4, Mr. Witt. There we go. There we go. And now all you have to do is just add 8 to both sides. I mean, who doesn't like adding 8? You know, go ahead and add that 8. Stop being stingy. Go ahead and solve for that y. Stop playing around. You end up with your answer. The answer is y equals negative 4/3 x plus 4. And yes, guys, you could use the slope-intercept form to solve that as well. Okay, so instead of using your point slope form, as I did right here, this line where I have y minus y1 equals to m times the quantity of x minus x1, you could use the slope-intercept form and solve for b and get that answer. You could do that. Okay, so just letting you know you got some options. Okay, I don't want to be stingy and just let you know that you have to do it that way. You can do it the other way and get the right answer. So that's just one way to do it. We're gonna move on because we got problems to solve here. Yeah, I was kind of debating on like showing you guys the other way to do it in this video, but then I was like, I have other problems to do, and this train doesn't stop. This train got one speed, and it's fast. We got to get through these problems, guys. We got to find an exam to study for. Problem number 4. We want to factor x cubed minus 216. Guys, you need to be able to recognize, okay? You gotta recognize that this is a difference of cubes. Shadow of Nexus says your explanations are so smooth and seamless. Greetings from Poland. What's going on, Poland? How you doing? Spreading that love around the world. I am receiving your love, Shadow of Nexus. I am putting it into my curio case of love from around the world. I didn't have love from Poland before, but now I do. I'm going to put a nice little spotlight on it, okay? So that the people that come by to visit me, they'll see your love from Poland highlighted within the curio. And there you go. There you go. All right. That's what's up. That's what's going on. All right, so let's continue. Hey, we have Anger Hermit, Mr. Witt. He helps you solve your problems. Not sure if math teacher or hitman. Well, it's a little bit of both because I do like to assassinate the math problems, Anger Hermit, and this one is about to die. Joanna Jones says this is a difference of cubes. Absolutely, Joanna Jones. Let me go ahead and give you guys the factoring pattern for a difference of cubes. When you see a problem in the format of a cubed minus b cubed, the factoring pattern for that is a minus b times the quantity of a squared plus ab plus b squared. Okay, so this is the way you factor a difference of cubes. The problem for many students, guys, is that many of you will not have access to this factoring formula during your final exam. So that means that you need to write down that formula as many times as you do it so that you can be prepared for your exam and you can have it memorized, hopefully, when it comes time for you to take your final exams. Every time you're using a formula in mathematics, write it down every single time. It helps you get more comfortable with the formula and it helps you memorize it. Empress is in the house. What's going on, Empress? Good deal. So what we are going to show here in problem number 4 is I'm going to show you guys what's being cubed. For one, I am going to show that x is being cubed and that the number 6 is being cubed. That's right. 6 to the third power is 216. Aspect says, Mr. Witt, you know all you have to do is shave your head to be Hitman, Silent Assassin. Already there. Good stuff. Good stuff, Aspect. In the house with Hitman. All right. So now that I've identified that my A value here is X and that my B value here is 6, I'm going to be using substitution into this factoring pattern to factor problem number 4. So that means that the first set of parentheses here is just simply X minus 6. Just following the fact that A being X and my B being 6, I just plug those straight in to the factoring pattern for a difference of cubes. From there, they're asking us to square this first value. So that means that x squared is, well, it's just x squared. There you go. Then you must have these exact signs within the trinomial here. So because they're saying that you have to have a plus sign, then I have to have a plus sign as well. And then they're saying to multiply the a and the b values. Well, our a and b values are x and 6. So we'll end up with 6x when you multiply that together. Then you got to have that plus sign. So put the plus sign there. Go ahead and put that plus sign there. Stop being stingy. Why you being stingy? Put the plus sign right there because it's right there from the formula. Okay? Put that plus sign there. Then they want you to square the 6. So squaring the 6 gives you 36. And guess what, guys? This is the answer. And you know what? Oh, I know what you're saying. But Mr. Witt. Can I factor that quadratic trinomial right there in that parentheses, Mr. Witt? No, you can't. Because it's prime. That's why. There aren't two factors of 36 that'll add to give you 6. So that will always be the case when factoring a difference of cubes or a sum of cubes. The quadratic factor that you have in your answer will always be prime. You never have to worry about factoring that quadratic trinomial. When you are factoring a difference of cubes or a sum of cubes, you better go ahead and put a red box around your answer right now. Red boxing it. That was problem number 4, guys. Do you feel me out there? Because I'm going on to problem number 5. And in problem number 5, what's going on? Janae is in the house. Janae says, hi, Mr. Witt, it's me, Justin. Oh, Justin Norwood, what's going on, Justin? There you go, using your mama's account. It's all good. I'm just checking you out before I go to swim practice again. Stop being stingy. Exactly. All right, well, have a good time in your swim practice there, Justin. Thank you for chiming in. I really appreciate you taking the time out to hang out with Mr. Witt for a little bit. Joanna says, red boxing it. That's right, Joanna. Let's go about this problem number 5 here. Asher says, how come it's not negative 36? Because they said to square the b value in that previous problem, Ash, and our b value that we identified was the number 6. So 6 times 6 is going to give us 36. And also because the factoring pattern says that that last sign, that last number, had to be positive. So you have to follow the factoring pattern. Let me go ahead and go back and show you real quick, Ash. Notice that our factoring pattern here says that this has to be a positive b squared. So the signs in that quadratic trinomial there, it has to have the exact same signs as in the factoring pattern. That will always be the case. All right. And we said that it was the number 6 that was being squared here. So when they said the b needs to be squared, our b value is 6 in this case. So we have 6 squared, which is 36. And that's how we ended up with that positive 36. I hope that helped. Ash from my class. All right, let's see who else is in the house here. So then we have Gall 6 saying, have I done any logarithms yet? I will probably be doing some logarithms, Gall, next week when I'm dealing with college algebra. This particular final exam doesn't have any logarithms in it, but you can find about 3 logarithmic videos on our channel. Okay, so if you just go ahead and look up logarithms on Fort Bend Tutoring's YouTube channel there on our homepage, you should find at least 3 videos on logarithms. All right. But we will be going over some logarithms for final exams next week, Gall. But thank you for chiming in. There you go. That's right. Aspect says, this morning my college math teacher reviewed this with us, and that's funny. All right. So you appreciate me having a little personality. There you go. There you go, Aspect. Well, let's get to number 5. We can't have people waiting. Let's get with number 5 right now, Aspect. So when you have function notation class, which is what we have in this problem here, that f of x is just a substitution for the variable y. Yeah. Anytime you see f of x, g of x, h of x, any of these of x's things, all right, there you go. There you go. Logs are not OP when you know what you're doing, Electo. Okay, Electo says that logs are OP. No, they're not OP when you know what you need to do. All right, Ash says she figured out what happened in that last problem. Awesome. Angry Hermit is coming with some logarithm links, guys. So thank you to Angry Hermit for helping out with the links. So going back to our problem that we're dealing with right now, and that is evaluating functions. You have a problem in function notation. We know that because they're using this symbolism, this f of x, which means that you're in function notation. All right. It is a substitution for the variable y, but it also allows the author, the maker of the problem, the creator of the problem, to tell you to replace all the variables, all the variable x's in this expression, in this equation, with the number -1. They want you to plug in -1 for x and then simplify it. Yeah, that's what we got going on there. Good job. So Gall says, thank you so much. I really appreciate you taking the time for the benefits of others, but I have problems with this stuff too. No, I understand, Gall. And that's why you can go ahead and check on those links that Angry Hermit just posted that will go over logarithms for you. Thanks so much, Joanna, and Angry Hermit for chiming in on that. So this problem, guys, evaluating functions. You're going to replace all the x's in the equation with the number -1 and then simplify it. That's what's going on. So I'm going to replace every x with -1, and then I'm going to use the order of operations to simplify this. And that's all you got to do. It's literally plug and play. So I'm going to start out with my exponents first. So I know that -1 squared means -1 times -1, which is +1. And then I'm going to have +5 times -1. Then we're going to have +6. Pick up sticks. RNF says hello. Hello, RNF. Are you planning to do a calculus final exam? Yes, I am, RNF, but that's going to be probably somewhere at the earliest, sometime mid-June or something like that. It's most likely going to miss the spring semester students. And the reason for that is because I am still warming up to doing live streams, and also because I want to help the majority of people that are taking their exams right now. And calculus is a bit on the specialized part of specialized stream. Yeah, anyway, not that many people take calculus, all right? That's what I'm trying to say. And the bottom line is I will be doing that in the summertime. It will not be done from me in time for the spring semester. But I'm going to be doing one, all right? I will be doing one. But it's not going to catch you for spring. But you can find some of your concepts already on our YouTube channel, but very few. I have to flesh out that calculus playlist a lot more. Okay, and I will be doing that in the future. All right, good deal, good deal. Let's see. Aspect as far as punching things into the calculator, it depends on how you plug in things into the calculator, and plugging in things into a calculator depends on what model. That's why sometimes the answer doesn't come out right. It's not the calculator's fault. It's the way you're inputting it. All right. Yes, we will have a composition problem, Electo, and let's just get back to some problems so we can get there. All right. Let's see about that answer, Joanna. So here we're going to be multiplying next. We have 3 times 1 and 5 times -1. That gives us 3 minus 5 plus 6. So when we combine our like terms here, working from left to right, I have 3 minus 5 is -2. And then -2 plus 6 gives me positive 4 as our result, Joanna. We have positive 4 as the answer. Done and done. That's it. Yeah. When you have to evaluate a function, you're going to replace all the variables with the given value within the parentheses. So they're saying to find out what f of -1 is. So we replace every variable x with -1, and then we use our order of operations to simplify that. So we had to square the -1. That gave us positive 1. And then we multiplied next. So that 3 times 1 was 3. 5 times -1 is -5. We bring down that 6. And then working from left to right, 3 minus 5 is -2. -2 plus 6 gives us positive 4 as our final result. And we, of course, red boxed it. Problem number 6, guys. Hey, Electo, didn't you just say, do I have a composition problem? Here it is. Here it is, Electo. Problem number 6. How about that for service? You asked for a composition problem, and I give you a composition problem right now. There you go. See? Here to serve the public. Mr. Witt and Fort Bend Tutoring. It says to find the composition of f and g for functions f of x equals x plus 6 and g of x equals 8x minus 9. All right, let's find this out, guys. All right, and once again, I want to remind you guys to share the stream, please. Go ahead and like the stream. Subscribe to Fort Bend Tutoring, and if you're able, donate, as that helps us bring you more free math tutorials from me, Mr. Witt, and Fort Bend Tutoring. All right. There you go. We did need to square the 3 in that previous problem, Joanna, because the exponent was not on 3. It was only on the -1. All right. So there you go. Good question, though, Joanna. Appreciate you. Okay, so here, guys, f composite g of x. This means to replace every variable of x within the f function with the entire g function. Well, you may be saying to yourself, well, that looks cute, Mr. Witt, but really, what does that mean? Really, what does that mean? All right, Saya has to go, guys. So appreciate you stopping in with us, checking in with us. Saya, I appreciate that. You have a good evening, sir. Have a good one, Saya. Thank you for chiming in. All right. Done and done. So here we go. Check this out. We, guys, we're going to replace every variable in our original function f with the entire function of g. Let's see how this looks. So recall that f of x equals to x plus 6, right? And our g of x equals to 8x minus 9. But as I told you guys before, we're actually going to replace every variable in the function f with the entire function g. What does that look like? Well, let's see. Our function f says x plus 6, right? So the x will be replaced with 8x minus 9. So I'm going to show with parentheses I'm replacing that x and f with 8x minus 9. And then we have to add 6 to that. right? Because our original f function said x plus 6. See, I've replaced the x in our f function with the g function 8x minus 9. Yeah, that's what's going on there. That's what's going on. So we had that original f of x function that had x plus 6, but the function that's composition here is saying to remove the x and replace it with the function g of x. So I replaced that x in the original function x with 8x minus 9. From here, we're going to be combining our like terms and simplifying this. So we can just simply drop that set of parentheses. I was only using that to show you guys what I was substituting. You know what I'm saying? But the lazy Mr. Witt wouldn't have even written that in the first place. But what I will do is go ahead and combine my like terms over here, because we have -9 and +6 to give us -3. And I'm going to red box this because this is the right answer. Oh, it's over. What are you waiting for? Red box it. That's problem number 6. All you do when it comes to composition is substitute and simplify. That's it. Yeah. That's all you have to do. Yeah. So f composite g of x means to replace every x in f with the function g. And that's exactly what we did. We took away that, we substituted that variable x with all of g of x, which was 8x minus 9. And then we continued with the rest of f, which was plus 6. And then we combined our like terms. And it's over. I got a red box around this. I'm moving on to the next problem. That's right. Problem number 7. With problem number 7. There you go. All right. Okay, Justin, go ahead and have fun at your swim practice. Appreciate that. That's right. You can catch me on Saturday. That's right. I'll be Central Standard Time. I'll be on here at 10 a.m. And guys, you can also go to our YouTube channel and click on the bell notification, that bell icon. It'll let you know every time I am live. That's right. Every time Forbidden Tutoring has live content for you guys to digest, consume. Problem number 7. They want us to find the quotient and the remainder when 3y cubed minus y plus 4 is divided by y minus 2. We're going to use the process of long division to solve this. You actually could use synthetic division to solve this problem, but usually nowadays synthetic division is kind of saved for college algebra and classes above that. So we're going to be using long division to solve this problem, guys. All right, so there you go. There's an alternative to solve this problem called synthetic division that I won't be going over right now because it's not for intermediate algebra. Nope. We'll be doing long division, guys. So if you are in college algebra, then you already should know that college algebra, they want you to be able to do it in long division and in synthetic division. That's right. So here we have an example of long division. And what you need to remember is that when it comes to the divisor and the dividend, you want every term represented. So what do I mean by that? I mean that notice how I've included this 0y squared term. The reason for this, it's a placeholder because as I'm working through my division process, I don't want to misalign. Okay, I don't want to. I want to be organized. Okay, I want to do that. I want to be able to align my like terms together throughout the process, and I won't be able to do that if I'm missing a term as far as the degree of y is concerned. Notice that our highest degree here is y cubed, right? We didn't have a y squared term, so I need to have that. Angry Hermit just posted the synthetic division link within the super chat. Thank you very much, Angry Hermit. And then we have minus y to the first power plus y to the 0 power, practically. There you go. See, so my exponents on my variables y go down. You know, they're in descending order. We have 3, 2, 1, and none. Or 0 if you want to say. Okay? So that is how I set up my long division problem. Now, as far as executing it, you want to make sure that you're paying attention to the first term in that divisor, that y. And you're going to ask yourself, what can I multiply y by in order to get 3y cubed? What times y gives me 3y cubed? And that answer, guys, is 3y squared. And now you'll be distributing this to each term. So 3y squared times y gives you 3y cubed. Oh, yeah, it does. And then 3y squared times negative 2 is negative 6y squared. And then after you distribute, you must always change the signs, guys. This was always a part of your division process, especially when you're dealing with long division, that you always, after multiplication, you always, aka subtract, aka change the signs of those values to get to our next step in the long division process. So that means that the 3y cubes can now cancel out. That now that 0y squared and that 6y squared combine to give me 6y squared, and I'll bring down that next term, which is negative y. We want to take our first term again, that y variable, and see how many times we need to multiply it to get the 6y squared. So that means that we'll be multiplying this time by 6y. Multiplying by 6y, we'll have 6y times y, which is 6y squared. We'll have 6y times negative 2, which is negative 12y. And then we will change the signs, guys. There you go. David Ramirez says, you're doing excellent work, service, Mr. Witt. Give me that WHITT, David. WHITT for that wit, please. Thank you so much for your math videos. My pleasure, David. It is my pleasure to serve. There you go. So I appreciate you viewing the videos that are produced. All right. I really appreciate that. And thank you for spreading the word out there, guys. Much love from me, Mr. Witt, and Fort Bend Tutoring, FBT, where personalized tutoring is the solution. That's right. There it is. From here, we will be changing the signs, guys. That's right. So after you multiply, aka distribute, you need to change the signs at this step, and then we'll be able to continue on. So now we have negative y plus 12y, which gives me 11y, and then we'll be bringing down that next term, which is the positive 4. That's right. Appreciate that, David, with that WHITT. Much love to you. Thank you. We have to multiply y by what in order to get 11y? What did you say? What did you say? Exactly. You have to multiply by 11. Exactly. Oh, yeah, I heard you. I heard you. All right. So you have 11 times y. That gives you 11y. Yes, it does. 11 times negative 2 is going to be negative 22. And then you're going to change the signs, guys. That's right. Your 11y's cancel out. You'll have a remainder of 26. Pick up the sticks. So the quotient, ladies and gentlemen, is going to be 3y squared plus 6y plus 11. However, because y can't become 26, all right, as a polynomial, as a monomial, then you're going to end up with 26 as your remainder. And since the question is asking separately for the quotient and the remainder, we're going to say that the remainder is 26 in this case. All right, because if we were going to include the remainder as part of the answer, you would have had it written like this. All right, so if they would have just said find the quotient of this, we would have had the problem written as 3y squared plus 6y. The quotient would be looking like this, guys, plus 11 plus 26. Let me fix that plus sign. I hate it. I hate it. I hate it. There we go. Plus 26 over the divisor of y minus 2. See, the answer would look like this if they wanted just the quotient of that. But since they separately wanted the quotient and the remainder, we're saying that the quotient is 3y squared plus 6y plus 11 with a remainder of 26. So because of the way the question was asked, we separated the remainder and the quotient from each other. But if they wanted it all in one, you would write your answer like this. Okay, so let me go ahead and put that in purple since that's not what they really wanted. We're going to give them a little purple circle. That's what we're going to do. That's not what they wanted, but if they did, that's what it would look like. But what they wanted is in a red box in it. And that completes problem number 7, guys. And we're now on problem number 8. And we're trying to keep it moving so we can get to more problems, guys. In problem number 8, it says find all numbers not in the domain of the function. Well, the things that are not in this function, guys, are going to be values that will generate a 0 in the denominator. Remember, you can't have a 0 value. You can't have a value of 0 in the denominator of a fraction or a rational expression for that matter because it's undefined. You can't divide by 0 in mathematics. It's just not possible. So therefore, the only domain restriction that we have in this rational equation is having 0 in the denominator, something we can't have. So go ahead and set the denominator not equal to 0. That's right, Joanna, a purple circle.
You got it. So we end up with x squared minus 2x minus 48 cannot equal to 0.
Because these are the things that would not be found in the domain of this function. Oh, yeah.
And notice, guys, that it is a quadratic equation of sorts. Technically, if I can get my words together, this is a quadratic inequality right now because of the not equal to sign.
But we can use the zero factor property to assist us if this is factorable.
So the question is, are there two factors of 48 that'll subtract to give us 2? Let's see. I know that factors of 48 are 1 times 48. I know that I have 2 times 24. I know that there's 3 times 16. I know that there's 4 times 12. I know that there's 6 times 8.
So 2 factors of 48 that'll subtract to give us 2.
Oh, yeah. It's 6 and 8, guys. It is 6 and 8. And I'll be opening up 2 sets of parentheses. Oh, yes, I will. Oh, yes, I will. Open up 2 sets of parentheses. And I'll have my variable x as the first term in each one. And I'll have my factors, 8 and 6. I always like to lead with the
biggest factor when I'm factoring a quadratic trinomial, which we have 3 videos for, by the way, guys. There are 3 videos on factoring quadratic trinomials on Fort Bend Tutoring's channel.
There it is. The sign of the middle term's coefficient must be the sign of the largest factor. So the 8 has to be negative. Since we're subtracting,
the 6 has to be positive.
Very good, Joanna. You got it. And now we'll be setting each factor not equal to 0 and solving for it. So we'll have x minus 8 cannot equal to 0 and x plus 6 cannot equal to 0. And then you'll solve for each inequality here. I'll be adding 8 to both sides to find out that x cannot equal to 8. I'll be solving for this variable and subtract 6 to both sides to find out that x cannot equal to negative 6.
So as far as finding out
the values, the numbers that are not in the domain of this function, those values are negative 6 and 8. So as a solution set here, let's see if we were put it in set builder notation. We'll say, oh, that's an ugly brace. Let me fix it. Oh, that's an ugly brace. Can I fix this brace? That's better, guys. We'll say that x is such that x cannot equal negative 6 and 8. And there we go. Red, boxing it. That's it.
So as far as finding out, guys, all the numbers that are not in the domain of the function, the numbers negative 6 and 8 are the values that are not in this function. In other words, x is such that x cannot equal negative 6 and 8. Red, boxing it. There you go. All right. Well, we have a question here. Or do we have a question that says, hello, do you have any videos on adding vectors or quadratic optimization? Not at this time. Neither of those topics are on Fort Bend Tutoring's channel at this time. Sorry about that. All right. Thanks, Angry Hermit, for the playlist for factoring quadratic trinomials. Appreciate that. Excellent. Yeah.
All right. Let's move on to our next problem, guys. That was problem number 8. We're trying to hit as many problems as we can today. And in this problem number 9, we're going to find the product. 9p minus 1 times 81p squared plus 9p plus 1, guys. Oh, yeah. And here we have a binomial, meaning 2 terms, times a trinomial, meaning 3 terms. Yeah. And if you don't know me by now, let me educate you about Mr. Witt. Mr. Witt is about to get his arrows popping. That's exactly what I'm about to do. Oh, yeah, because I love the distributive property. And you can call it what you want. You can call it the FOIL method, but we're just doing the distributive property, my favorite property in the world. Let's get these arrows popping on these people, guys. They're not even ready for us. Not today, they're not. Oh, they're not ready for these arrows popping everywhere. There you go. So let's go ahead and do this. That's right, David. We're going to pop these arrows today. You see what I'm saying? Like machine gun, popping those arrows. We have 9p times 81p squared. That gives me 729p cubed. Joanna says they really helped me for sure. That's right. Arrows popping helps everybody. Go ahead and get your arrows popping t-shirt from Fort Bend Tutoring's t-shirt shop, guys. There you go. Go ahead and hook that up. We got a link in the description box. Angry Hermit says, I'm hyper today, Mr. Witt. Give me some of that energy. I'm giving it to you right now, Angry Hermit. I'm giving you all this energy. All right, because I'm excited about this intermediate algebra final exam review. There you go. Let's continue this distributed property prop. There we go. We have 9p times 9p to give me 81p squared. There you go, guys. I hate that p. Let's fix the p. There we go, 81p squared. What's going on, Kaylee? How you doing, girl? Good to see you. 9p times 1 is going to be 9p. Yes, it is. Now we're going to distribute the negative 1. That's right. We have the negative 1 being distributed to each and every term. So the negative 1 times 81p squared is negative 81p squared. Oh, yes, it is. The negative 1 times the 9p is negative 9p. Thank you. The negative 1 times 1 is negative 1. And guys, just to let you know how you can keep up with all of your terms when you're multiplying, notice that we multiplied 2 terms times 3 terms and ended up with 1, 2, 3, 4, 5, 6 terms. Notice that 2 times 3 is 6. Kaylee has a nice happy face going for herself today. Thank you very much, Kaylee, for that smile. I appreciate that. Love your smile, Kaylee. From here, guys, we're going to be combining like terms. Electo says 729 is the root 27. Let's see here. 729. No, I want to say no. This is root 29. No, I want to say no. 27 times 27? It might be. Yeah, that sounds good. Yeah, I think you're right. There you go. Angry Hermit says, you love her smile, but do you also love my scowl? Your scowl. Sometimes, Angry Hermit. It depends on my mood. But I love you nonetheless. That's all that counts. There you go. Hey, 729. What is this question? What is this question you have? Huh? I know that 81. I know that 9 times 81, right? Gives you 729. And then so that breaks up to 9 times 9 times 9. So no, the answer is no then. Yeah. Or is it no? Let me figure it out. We got 3 times 3 times 3 times 3 times 3 times 3. Yeah. You're right. The square root of 729 is 27. You're making me do extra work here. Thanks a lot, Electo. Yes. The square root of 729 is 27. Okay? There you go. Not that we need that right now, though, Electo, but thanks. Electo says my calculator said so. Thanks a lot, Electo. Good to see that you got that calculator working right now. So continuing on with this problem, guys, because this is so sidebar that I'm going to section this off from the world. Guys, this has nothing to do with this problem right here. But that was Electo's question. There you go. We're going to section that off. This part down here is quarantine. This is the quarantined area of the problem because this has nothing to do with that up there, guys. All right. So anyway, that was a sidebar question from a sidebar. There you go. So let's bring down. We have 729 p cubed. Our p squared terms will cancel out, guys. They're gone. 81p squared minus 81p squared. It's gone. The 7p minus the 7p. It is gone, guys. And we're left with minus 1. So that's our answer. This is a difference of cubes, guys. This result is called a difference of cubes. There it is. 729p cubed minus 1 is the answer to problem number 9. Electo making me waste time after I told him I was trying to get through as many problems as possible. Thanks a lot, Electo. So we have problem number 10. Simplify the complex fraction. Angry Hermit is going to hook up that link for complex fractions. Thank you so much, Angry Hermit, in advance. That's right. I took an orange juice break. What you going to do? All right. There are several ways to attack a complex fraction, but when I have multiple terms in the numerator and in the denominator, I like to multiply each and every term, each and every element by the LCD of the entire rational expression. Yeah, that's what I like to do. See, I have denominators of x, 4, and 8 showing. Thanks, Angry Hermit. So if I multiply each and every term by 8x, I can kill the complex fractions within this problem. Oh, yes, I can. Notice how I'm showing you that arrows will be popping. Oh, yes, they will. And what we will do is I'll take this area over here. Let me go ahead and create an area over here for the people that are watching. This area over here to the right, I'm going to use that for my slow motion area. Yeah, we'll call this area the slow motion area. Thank you. Yeah, That's what we'll do. So starting out, I'll be multiplying 4 times 8x. Well, we're in slow motion. 4 times 8x is just going to be 32x, right? Okay, so my first term in the numerator is 32x. That wasn't so bad, right? Then the next term I'll be multiplying is 2 over x times 8x. All right, let me fix my 8x here because it's rather ugly. I think I can do a better one. Oh, that's better. There you go.
So what happens is, have I done factoring yet? I did factor some of in one of the problems so far. Yeah, and we actually have a link up above us in the chat that says something about factoring. Gigi says, how did you get 8x to multiply by?
Gigi, I got that by looking at all of the denominators in the complex fraction. I have x, 4, and 8, right? So as far as the numbers are concerned, we know that 4 can go into 8, right? And 8 goes into itself, so we got to use 8. But then we have this variable x down here too, so I just multiplied that together.
Yeah, so that's the least common denominator of all of the fractions that we have showing in this complex fraction. So basically, I looked at x, 4, and 8 to get 8x as the least common denominator overall. So I just looked at all the different factors to see what was the first term that they can all go into evenly, and that was 8x. Amen, amen. All right, Angry Hermit is coming with that least common denominator link from FBT
to help out GG. All right, good deal. From here, the x's will cancel out, guys. So 2 times 8 is just 16. So we'll end up with 16 as a result of multiplying 2 over x by 8x. From here, guys, we will be doing the following. We'll be multiplying x over 4 times 8x. And I'm going to simplify this because 4 goes into itself once, 4 goes into 8 twice. So you'll end up with a result that is 2x squared after multiplying x over 4 times 8x. You'll end up with 2x squared.
That's right. No problem. No problem, Electo. I don't want to ignore your comments, Electo. I was just joshing with you.
I just need to be focused on the time. That's all. Please ask your questions, Electo. This stream is not the same without you. So I need your comments. I am waiting on them, Electo. So what we're going to do here, we have 1 over 8 times 8x. The 8's will cancel out, and you'll end up with x. So we're going to have 2x squared plus x. Done and done as far as simplifying the complex fractions. But you're still responsible for reducing this rational expression as much as possible, okay? So what we're going to do now is take a look at what will occur if we were to factor out the GCF in the numerator and the GCF in the denominator. Thanks for the video. I got to go to swim practice. I understand. Have fun at swim practice. You and Justin are going to swim practice today. Awesome. Take care and be safe, of course. All right. Good deal. So now we'll factor out 16. Look at Gigi being nice, saying thanks to Angry Hermit. Angry Hermit, Gigi, Gina is she's my current student right now that you're helping out, being all nice too. I appreciate that.
We were just hanging out last night in class. That's right. Mr. Witt teaching in the evening.
Good stuff. Then in the denominator, our GCF is 2x. So factor out, no, guys, that's a lie. It's not 2x. Our GCF in the denominator is just x, all right? So that'll leave us with 2x plus 1. And now, simplifying this result, when simplifying this result, and yeah, we're going to assume that we don't have any restrictions in this problem, meaning that this x is not going to be equivalent to negative 1/2, that this x will not be equivalent to 0, okay, because that would violate the domain of the expression, making it undefined, either of those choices. And they didn't make any stipulations in the directions now, did they? No, they didn't. So we're assuming that there are not going to be any domain violations by the process that we're doing right now, which means that our next step is to simplify this further by canceling out these like terms right here. Since everything is multiplying and dividing at this point in the problem, you can cancel out the common factors. So basically, I'm just saying 2x plus 1 divided by 2x plus 1 is 1. And 1 times anything is itself. So that means that our result here is 16 over x. And we are going to red box this answer number 10, guys, and done. That's right. Problem number 10 is done, guys. Let's keep it moving, please. Keeping it moving. Here we go. In problem number 11,
It says that one maid can clean the house 3 times faster than the other. Working together, they can clean the entire house in 3 hours. How long would it take the faster maid cleaning alone?
So let's go ahead and set up a 3x3 table here. All right, that's what I'm going to do. Set up a 3x3.
And this is a work problem, guys.
So we're going to have our columns labeled as R for the rate, T for the time, and W for the work being done. So I am using the formula work equals to rate times time, guys. That's what I'm using.
Work equals rate times time.
So we're going to have the fast maid, the slow maid, and them, let's fix that slow, the slow maid, and them working together. Okay,
that's what I got. And let us go ahead and organize our data. So when it comes to many word problems, guys, and you can check out our word problems videos, there's a playlist for that. That when it comes to work problems, I love to set up a table just to keep everything organized.
Okay, so this is what I have thus far.
I have this organized.
So organizing this, we know that they're all going to be doing one job. And what is that one job, you might ask?
This one job is cleaning the house. Yeah, they're cleaning one house.
So that's the one job being done. And the fast maid will do it in X amount of time, because they didn't tell us exactly how long the fast maid takes. But we do know that the slower maid will take 3 times as long to do the job. So let's say if the fast maid does it in 1 hour, then 3 times that hour will give us the time of the slow maid. They'll take the slow maid 3 hours to do it, right? But we do know that they can work together to clean the entire house in 3 hours.
Okay, so that's what we have going forward.
Okay, now check out my equation over here.
I told you that I'm using the formula, all right? Work equals to rate times time.
And what I'm missing is the rate. So let's solve for the rate, this R value. So by dividing both sides by T, we can figure out that the rate is equivalent to the work, that's supposed to be a W, guys, is equivalent to the work divided by the time. And since I have my formula now for the rate, we can figure out that the fast maid's rate is 1 over X, and that the slow maid's rate is 1 over 3X, and that working together, their rate is 1/3. In other words, the fast maid can clean that one house in X hours. The slow maid can clean the same house in 3 times as long, or 3X hours, and then together they can clean that one house in 3 hours. And it's this, class. It is this, ladies and gentlemen, that's going to be your equation. This right here. We're going to go ahead and cut this out. Let's go ahead and see. Let's go ahead and see if we can cut this out. Go ahead and stay in the lines, Mr. Witt. We're going to copy this. All right. And then, yeah. Let's hook this up, guys. Let us hook this up. We're going to put it here. Yeah. We're going to, right here. We'll put it there. That's where we're going to put that. And now it is this first column that will give you your equation that you need. Let me show you. You'll have the following equation, guys. You'll have 1 over X plus 1 over 3X has to equal to 1 over 3, 1/3.
Yeah. So let me explain what's going on here.
I'm saying that the rate of the fast maid plus the rate of the slow maid has to equal of the rate of them working together.
And that is how you end up with the proper equation, or at least one equation, to solve this word problem.
And because we have a rational equation now, guys, we will be multiplying each and every term, GG, by the least common denominator of the entire equation, which in this case is 3x. So I'm going to multiply each and every term, guys, by 3x. Because I don't want to deal with these fractions. So I'm going to eliminate these fractions by multiplying each and every term by the LCD of the entire equation.
Yeah, that's what I'm going to do. Joanna says that I'm smooth with it.
I'm trying to be, Joanna. I am trying to be. The x's will cancel out, guys. I end up with 3 times 1, which is 3. The 3x's cancel out in that second term to leave me with 1. The 3's cancel out, guys, to leave me with x. Guys, do you know that 3 plus 1 is 4 hours? What?
Are you telling me that we have the answer?
Let me go back and look at this question again, guys. This question said, how long would it take the faster maid cleaning alone? We said earlier, guys, that the fast maid does it in X hours. Didn't we just solve for X? Did we not just solve for X? Did I just not put a red box
around my answer. Done and done, guys. Done and done. The answer is 4 hours. The fast maid will clean the house in 4 hours, which means that the slow maid is 3 times as long. Will take them 12 hours to clean that doggone house. Yeah, it's like that. That was problem number 11. I am so moving on. What's up on that word problem, though? It is done. It's done. That's right. There you go, Angry Hermit. Angry Hermit said, oh my God, 1 plus 3 equals 4. She never knew. Now you know, Angry Hermit. Now you know that 1 plus 3 is 4. You get all that information from Mr. Witt. Hey, we got problem number 12, guys. They want us to solve for x. We have another rational equation. Well, after that last problem, we're not scared of this. After that last problem, we're not scared of that. No, Electo, it's just 4 hours, not 4x hours. All the x's canceled out on that left side just to leave us with 1 plus 3. And we did red boxes, Joanna. You got to believe that. In problem number 12, we have solve for x. We have 1 minus 3 divided by 2x equals to 7/4. And in order to, that's right, Kaylee, in order to solve for our variable here, I want to get rid of these fractions first. That's what I want to do. You got it. So what I'm going to be doing now is realizing that as far as the LCD is concerned, I need a number that 2 will go into evenly, that 4 will go into 2 evenly, and that x will go into evenly. So we're looking at an LCD of 4x. That's right. And I'll be multiplying 4x times each and every term, guys. That's exactly what I'll be doing. Now, when you're dealing with rational equations, guys, you do need to be aware of your domain restrictions. So from the beginning, we should know what values will cause this equation to be undefined. And what will cause this equation to be undefined is having x equal to 0. X can't equal to 0 because 2 times 0 is 0, right? We can't have 0 in the denominator of a fraction. So be aware of that when you are solving your rational equations. You need to be looking out for extraneous solutions. All right. So when you get your answer, especially if you haven't defined the domain from the beginning, you want to plug in your results. All right. To verify that they will work in the original problem. Oh, yeah. That's what you're going to do there. All right. So here we go. Angry Hermit, I would play with you right now, but I gotta get back to this problem. Angry Hermit up there talking about she needs more proof about 1 plus 3 equals to 4. All right, I'm gonna get back to you on that one, Angry Hermit. So here we have 4x times 1 is gonna be 4x. Here the x's will cancel out, and 2 goes into 4 twice, so negative 2 times 3 is negative 6. And our 4's cancel out here. X times 7 is 7x. So at this point, I'm going to be subtracting 4x to both sides. All in an effort to solve for the variable. 7x minus 4x is 3x. And then we'll be dividing both sides by 3. And x equals negative 2, guys. That's right. But it's only negative 2 if this answer does not create a 0 in any denominator in the original problem. And it doesn't. See, if I plug in negative 2 into this denominator above, the 2 times negative 2 is just negative 4. That's okay. We can have that. All right. In fact, we can verify that this works, class, because if we have 1 minus 3 times 2 times negative 2 is negative 4, right? There we go. This gives us, when we combine the signs, 4/4 plus 3/4, which does equal to 7/4. So that checks out. This is the answer. I am going to red box it. Done and done. You got it, guys. That was problem number 12. So not only did I solve the solution, I plugged in my result into the original equation to verify that it truly was indeed the answer to the rational equation. You must check your result to make sure that it doesn't create an undefined situation. And even more so, I proved that the left side was equal to the right side, so I know for certain that negative 2 is the solution to problem number 12. And we are moving on, ladies and gentlemen. I'm moving right along. There we go. Problem number 13. They're asking us to simplify this rational equation. Rational expression. What's going on, Jesse? Jesse says that he was in remedial algebra 17 years ago, studied many of your videos, and passed the math exam to go straight to algebra. That's what's up, Jesse. Way to go. I have made an A on algebra and a B on pre-calculus thanks to my videos. Appreciate you, Jesse. You are the bomb because you're the one that executed 2 things. One, you reached out when you needed help, you found your help, and then you actually applied that help and passed your exams. I'm so proud of you, Jesse. Good job. Thank you for feeding back. Give me some feedback. You know what I'm saying? Look at everybody congratulating you, Jesse. Joanna's saying way to go. Kaylee is saying awesome job. All right. We're all proud of you, Jesse. Good job. Appreciate it. Once again, guys, please share this stream with people that you know and love. And some of those people that you hate. And then tell your teacher tell your instructor about this stream. There you go. All right. Let's have some competition in the house. In addition to that, like the video, subscribe, guys. Appreciate you. And once again, if you're able, please donate, as that helps us bring you more free math tutorials from me, Mr. Witt, and Fort Bend Tutoring. All right, good deal. Let's go ahead and start by factoring the numerator. Muhammad says this channel is awesome and it helps me with my homework. Thank you, Muhammad, for utilizing the videos that we have posted. We are here to help. We're looking for 2 factors of 6 that will add to give us 5. That's going to be 2 and 3, guys. So factoring the numerator, you'll have y plus 3 times y plus 2. All right, that's the factorization of the numerator. All right, in the denominator, we're looking for 2 factors of 12 that will add to give us 8. So the factors of 12 that add to give us 8 are going to be 2 and 6. So we have y plus 6 times y plus 2. So now we have the numerator and the denominator completely factored. Electo says no need for college when you have FBT. I'm just trying to do my part, sir. Just trying to do my part. Helping the world, Mr. Witt. Appreciate that, Joanna, with that correction. Once we have everything multiplying and dividing here in problem number 13, we will be able to simplify, cancel out those like factors, the identical factors that we have in our rational expression. And you know what? We can kill the y plus 2s. They're dead. They're gone. And because y plus 3 and the factor y plus 6 is not an identical factor, the binomials, was that a word? Let's try that again. These binomials are not the same. You can't cancel them out. That's what's up, Kaylee. Trying to get my mouth to work right. We're going to red box this. Guys, now you see how tempting it is to try to simplify those y's, to try to simplify the 3 and the 6. You can't simplify those because they're adding now. See, now that you got those addition signs in there and stuff, you can't do that. You can't cancel it out. So you know you can't cancel out the y's. No, you can't cancel out. You can't reduce the 3 and the 6. This is the answer as it stands. You can't do anything to that. All right. For instance, let's try to substitute just for an example, just so I can show you why you can't simplify this further. What if the value of y is 2? Would these numbers have anything in common? Would they? Let's see. 2 plus 3 would give you 5 in the numerator, right? Interesting. 2 plus 6 in the denominator will give you 8. See, they're not identical values, so you can't just cancel them out. So you got to leave them alone. Okay? They're fine. They're safe within the red box. No one's going to harm them. They're protected from the rain, from the wind. They're protected from you. Problem number 14. Problem number 14. We want to simplify the expression. That's what's going on. Yeah. Angry Hermit says, yeah, the school system is just too flawed in so many ways. Does Mr. Witt have something to say about your school system? Interesting. Jesse says, thanks, everyone. I'll be taking calculus next semester and will be reviewing all FBT videos this summer. Jesse, I do plan on putting more calculus videos on the channel this summer to help you out. All right. Hopefully they'll be there in time. What's going on, Bejan Chu? What it do? So we have problem number 14 where we're going to be simplifying the rational expression here. Well, I know that with this rational exponent, this negative 3/5 as an exponent here, the denominator of that rational exponent tells us what is the root of the problem. Literally, the index of the problem is 5. In other words, the problem is looking for perfect fifths. Really? Perfect fifths? How are you on your perfect fifths? I don't know what that mouth of mine was about to say. But anyway, yeah. We have the need to simplify this problem using perfect fifths. And it just so turns out that when you have 32 raised to the negative 3/5, that 32 itself is a perfect fifth.
It's 2 raised to the 5th power, which is also being raised to the negative 3/5 power. And now that I have rewritten my base of 32 into 2 to the 5th power, then what I can do is I can kill these 5s right here. They're dead now. Dead to me. I'll end up with 2 to the negative 3rd power. But with the negative exponent, we can eliminate that negative exponent by shifting this base of 2 to the denominator, so that we now have 1 over 2 to the 3rd power. And did you know that 2 to the 3rd power is 8? So this answer is 1/8 red, boxing it. Orange juice break. I'm back. No pulp. Minute Maid in the house. Problem number 15. With problem number 15, we are asked to simplify. That's right. David's in the house. What's up, David Laguna? Red boxing it, ladies and gentlemen. That's right. Those are things that Mr. Witt always say. That's right. There you go. That's right, Electo. Summer classes do move very fast. If you have difficulty in math, I strongly suggest that you take the class during the fall or the spring semester when you have 16 weeks. What's going on, Brian? What up, bruh? Okay, there it is. Kaylee, I love you for what you just said because that was funny. I'm not going to repeat it, though, because, there's kids watching. We have the square root of 3 plus 3 times the square root of 108 plus 2 times the square root of 75. You want to simplify the square roots as much as possible prior to adding them. Angry Hermit's in the house, and if Angry Hermit is still in the house, she is finding the link for the video, Adding Radicals. David says, you are the best, man. Thank you for the videos. Thank you for you, David. I would be nothing without you on YouTube. You know what I'm saying? Thank you for watching. You help other people find me when you watch the video, when you like the video, when you subscribe to the YouTube channel, when you donate to help us bring us more free math tutorials from me, Mr. Witt, and FBT. That's what's up. Help a brother out. We have the square root of 3, guys, plus 3 times the square root. We have 108 underneath the square root sign, and we are looking for the largest perfect square that goes evenly into 108. And that largest perfect square, guys, is 36. One way to find that largest perfect square, guys, one of 2 choices. You can do it by memorizing it, or you can break down 108 into its prime factorization. That's what you could do. That's exactly what you could do. We know that the largest perfect square that goes evenly into 75 is 25. Yep. Hey, it's 25 times 3. Let me fix it. There you go. Almost slipped up right there. Almost made a boo-boo. But I fixed it. There we go. Now, I'll be bringing down that square root of 3. Plus 3 times the square root of 36 is 6, guys. That leaves you with the square root of 3. Plus 2 times the square root of 25 is 5. Multiply that by that coefficient of 2 there. There you go. Get this mouth to work, man. Maybe it's the orange juice. It's messing me up. You think so? No, I'm getting my vitamin C. There you go. Get that vitamin C up in there. So we're going to multiply now. We have 3 times 6. That gives us 18, guys, times the square root of 3. I hate that 8. I hate the 8. Let's going to fix it. There we go. That's a better 8. What about that 8, though? Wasn't that 8 better? Is my 8 better than your 8? That's what you want to find out. Can you out-8 me? I'm going to move on. We have 1 square root of 3. Plus 18 square root of 3, plus 10 square root of 3. Yeah. Adding all of that together, you'll end up with 29 times the square root of 3. And we are going to red box it. There you go. Yeah. There you go. See, you have like terms once you realize that all of your square roots are identical. They have to have the exact same root and radicand. And if there's any variables involved, the variables got to be identical as well for you to have like terms when it comes to adding or subtracting radicals. Yeah. We're moving on, guys. We're moving on. I want to get as many problems done as possible. We have problem number 16. It says for f of x equals 3x squared minus 5x minus 11, the parabola opens. Your choices are upward, downward, left, right, Yeah. Well, what they're referring to in this particular problem is a vertical parabola. We know this because, as I told you before, f of x could be replaced with the variable y. That if you have the equation in the form of y equals to ax squared plus bx plus c, or if you have the equation in the form of y equals a times the quantity x minus h squared plus k, aka have the equation written in vertex form. If you have the original equation in either of these forms, if your a value is positive, then the parabola points upward. If your a value is negative, that means that the parabola is going to point downward. So this is what they're asking of us. They're saying, hey, is this parabola going to open upward or downward? So because our a value in this problem is 3, see, our a value is 3 in this case. Well, because that's a positive result, we're going to end up with an upward result. The answer is just upward. Yeah. Why is there a y there? Upward and red. Boxing it. That's it.
That's all they wanted to know, guys. Electo is correct. Up is the answer. Up is the answer.
That's all they wanted for that. I mean, you can dwell on this problem if you want to, but I'm moving on because it's over.
Yeah, we're in problem number 17 now. I'm trying to kill you with these problems. You know, get as many problems done as possible. This is review, man. I can't give you a review if I don't give you any problems. In problem number 17, it says rewrite. Can he say it? Rewrite. The expression by rationalizing the denominator. That's what we want to do. And you will never leave a radical in the denominator. So what we'll do is we'll rationalize that denominator by multiplying the numerator and the denominator by the square root of 11. Yeah, that's what we're going to do. That's right, Joanna. We red boxed that and we moved on. That's right. Joanna says it's not the OJ, but it might be. It might be. So we're going to be multiplying straight across now, guys. Multiply straight across as you rationalize the denominator.
You will end up with 3 times the square root of 55. In the denominator, the square root of 11 times the square root of 11 will be the square root of 121. However, you just created a perfect square in your radicand. So that means we can actually take the square root of 121, which is 11, and done, guys. Yeah, it's over once again. Yeah,
there's no more to do in problem number 17. Yeah, exactly, Angry Hermit. It's not the OJ, it's my brain. That's right. My brain is just on tilt right now.
There you go. Hey, guys, this looks like another language. Let me see if I can fix this. Because I was looking at it, and of course it's my own handwriting, right? And I was saying, what is an epiphany? I was saying that to myself. I was saying, what is an epiphany? And then I realized that, the word if and any is too close to each other.
So let me go ahead and read this over. Okay. It says, name the quadrant and once again, let me try it. Name the quadrant, if any, in which the point is located.
We have the point
-14 and 2.
So we are going to first identify the different quadrants that we have. We have quadrant number 1, we have quadrant number 2, we have quadrant number 3, and we have quadrant number 4.
In quadrant 1,
your x and y values are both positive, guys. In quadrant 2, the x value is negative, whereas your y value is positive. In quadrant 3, the x value is negative, the y value is negative. And in quadrant 4, the x value is positive, the y value is negative. And guys, do you see all of these faces here? Because I do. You see that? Like this guy, he just like, is he dead? Is that a dead guy right there? And this guy here, he's winking. Suspiciously. This guy is asleep.
Yeah, third quadrant is very asleep right now.
And this guy here,
no, we don't talk about this guy.
He has no friends. He doesn't have any friends.
So, because we have a negative x value, a positive y value, when they say name the quadrant
that this point is located in, we're looking for
what happened to my mouth?
We're looking for the quadrant that has a negative x value and then a positive y value, and that's got to be quadrant 2, guys. That's right. What's up on that Roman numeral, though? Huh? What you got on my Roman numeral?
Why you slipping?
On my Roman numeral, though. Orange juice.
Red box it. There it is. That's right.
Angry Hermit says that this guy in quadrant 4, he's a pirate.
And he's somebody's crazy uncle.
Or both. Jack Sparrow, anyone?
Jack Sparrow, anyone.
Problem number 19. It says to give the solution set for the absolute value of y plus 3 minus 5 equals 11. That's what we're doing. So in this problem,
we want to start by isolating the absolute value.
That's right. So in order to isolate our absolute value, in other words, to get the absolute value by itself on one side of the equal sign, we are going to add 5 to both sides of the equation. That's what we'll be doing. We have the absolute value of y plus 3, which equals 16. Now that we have that, ladies and gentlemen, you need to know that, once again, this absolute value is a distance problem. More specifically, it is the distance to 0. They want this value on the left to be 16 places away from 0. Well, that can occur at 2 different places on the number line. That can occur at positive 16, of course, but it can also occur at negative 16. And this is why you must create 2 equations to solve this one problem. Because we can be 16 places away from 0 at 16 or negative 16. And now that we have our equations set up, after we verified that this statement is possible, okay, that the absolute value can be equal to a positive number or 0, never a negative number, then you set up your 2 equations that would both be equidistant from 0. Both of these values are 16 places from 0, and then you solve for each equation. So that means I'll be subtracting 3 to both sides. We'll have y equals 13, or subtracting, I hate the or, let's fix the or subtracting 3 to both sides, you'll end up with y equals negative 19. There you go. Yeah, there you go. So these, what just happened? There we go. So these are our solutions, and we're going to hook it up in a solution set. See that this is where the ugly braces come into play. Why? Oh, that's better. I can use that one. We have negative 19, we have 13, and we will red box it, Joanna.
There it is. Done and done. That was problem number 19.
Guys, we're going to wrap it up today with problem number 20. Here we go.
In problem number 20, it asks us to simplify. Give the answer in standard form. So what we're dealing with is the division of complex numbers. Notice that in here, that symbol I will stand for the imaginary number I, which is equivalent to the square root of negative 1. So this is dealing with complex numbers, and when they're referring to standard form, they want us to write the real number before the imaginary number. They want us to write the real number before the imaginary number. So our standard form for a complex number is a plus bi, and the imaginary number itself is equivalent to the square root of negative 1. All right, so we're going to stop just in time for my mouth to implode on itself because, yeah, I can't talk. Thanks. All right, so we're going to be multiplying the numerator and the denominator by the conjugate of the denominator. And in order to find out the conjugate of the denominator of our division problem here, all you got to do is change the sign on that second term. So the conjugate of 5 plus 2i is 5 minus 2i. And the need to do this is because you do not leave an imaginary number in the denominator of a fraction. So we are rationalizing the denominator by eliminating the imaginary numbers in the denominator with the conjugate. Yeah. And we'll basically be multiplying the binomials in the numerator by the binomials in the denominator here. Okay. So you better believe that we will be getting our arrows popping. Oh, yes, we will. Yeah, we will.
Yeah, we're going to get some arrows popping here. So we're going to have 3 times 5 is 15. We have 3 times negative 2i is negative 6i. We have 5i times 5, which is 25i, guys. We have 5i times negative 2i, which is negative 10i squared. And then in the denominator, 5 times 5 is 25. 5 times negative 2i is negative 10i. We have 2i times 5, which is 10i. Thank you very much. Positive even. We have 2i times negative 2i, which is negative 4i squared. And this is what we end up with after multiplying those binomials together. Oh, yeah. So let's continue. And we'll continue by combining our like terms. So we have 15, negative 6i plus 25i gives you 19i. Then we have negative 10 times negative 1. Why is this negative 1? Because I squared is equivalent to negative 1. That's why. Yeah, there you go. So next, we'll end up canceling out our the middle terms in the denominator. They'll cancel, getting the words together. This is going to be minus 4 times negative 1. And now, in our numerator, we'll have 15 plus 19i. Oh, yeah, plus 10. Thank you very much. In the denominator, you have 25 plus 4. And then I think we're gonna continue on. Let's continue on somewhere. Let's copy this. Let's add a page. All right. Let's add a page. There we go. There we go. Let's get this going. Let's get this working here. Let's move this over there. Pop that in. Go ahead and paste that. Here we go. Back in action. We are going to now add the 15 and the 10 together. And that gives us 25 plus 19i over 29. However, we are responsible for writing our answer in A plus BI format, the standard form, which means that you need to separate the real number from the imaginary number. So separating our results here, you'll have 25 29ths plus 19 29ths I. Yeah. And this is the answer. That's it. I'm putting a red box around this. If you need to see more examples of problems like this, guys, check out our imaginary and complex numbers video, as it covers more problems like the ones that you just saw right there. Yeah. So, ladies and gentlemen, this is Mr. Witt with Fort Bend Tutoring. Thank you guys so much for chiming in to part 1 of our intermediate algebra final exam review. We'll be continuing with more intermediate algebra final exam review on this Saturday. So make sure you're hitting that bell notification so you get you'll get a notification. There you go. There we're going to be live. There you go. And you can chime in live with me. That's right, GG. You got to check it out. Thanks, Kaylee. Anchor Hermit went ahead and hit you guys up with that link. I know you need more now, GG. All right, so you got to check out the other videos that I already posted. But GG was in the house. Jesse was in the house. Joanna was in the house. Kayla was in the house. Anchor Hermit was in the house. Who else we had up in the house? Electo was in the house. Yep. We had Brian in the house. David in the house. That's right. Beijing Chu was in the house. Good stuff. And we had Saya in the house. Empress was in the house. That's right. Thank you guys so much. If I missed you, much love to you. And as always, please rate, comment, and subscribe. And if you're able, please donate, as that helps us bring you more free math tutorials from me, Mr. Witt, and FBT. Jenny was in the house. Peace. All right, guys. You guys take care.
Thanks for watching. We appreciate you hanging out with Fort Bend Tutoring. Like the video, comment, and subscribe. Hit up our website, tutoringmath.net, and set up a private tutorial with me and FBT. Oh yeah, baby.